Development of the Periodic Table, TEKS C.5a. After this lesson, you will be able to explain the development of the periodic table over time using evidence such as chemical and physical properties. This video is part 1 of a two-part series for TEKS C.5a and C.5b. Since the early days of mankind, several elements were identified such as silver, gold, copper, lead, and mercury. However, the first element to be discovered was phosphorus in the 1600s. As elements continued to be discovered, scientists needed a way to organize their data. In 1789, French chemist Antoine Lavoisier attempted to organize findings on substances he considered elements, grouping them based on their properties. In 1803, English chemist John Dalton began using symbols to represent elements. 4 decades later, German chemist Johann Dobereiner made a new attempt to organize the elements. He grouped elements into triads with similar appearances and reactions. However, this system did not work for all known elements. Scientists continued to look for additional ways to classify the elements. In 1860, the first International Science Conference took place in Germany. This opportunity allowed scientists to come together to share ideas. At that time, there were more than 60 discovered elements. Although scientists agreed on the existence of atoms and molecules, there was still much debate about other aspects, especially atomic mass. Once scientists resolved how to accurately determine atomic mass, scientists tried to find a connection between the atomic masses and properties of elements. British chemist John Newlands observed that when the elements were arranged according to increasing atomic mass, every eighth element seemed to have similar properties. Because this discovery did not hold true for all known elements, it was not widely accepted. After attending the International Science Conference in 1860, Russian scientist Dmitry Mendeleev noticed that by arranging the elements with increasing atomic mass, the elements' chemical and physical properties were similar within vertical families or groups. Based on the patterns Mendeleev observed, he left gaps in his periodic table for undiscovered elements and accurately predicted their properties. These predicted gaps showed a major leap forward in understanding. Here is an example of the predicted and actual properties of gallium and germanium. This led to Mendeleev being credited with publishing the first periodic table in 1869. During the late 1800s, Lord Rayleigh and William Ramsay discovered argon while studying atmospheric gases. Additional experiments led to the discovery of helium and other gases. The discovery seemed to contradict Mendeleev's work due to the unreactive nature of the gases until a new family was added to Mendeleev's periodic table. Mendeleev's periodic table worked for most elements, but some elements seemed out of place. Their chemical properties did not always align with their predicted position on the periodic table according to their atomic mass. You can see here that even though cobalt has a larger atomic mass, it is placed before nickel. The same is true for 2 other pairs. In 1914, Henry Moseley's work with X-rays showed that each element had a unique atomic number. He rearranged the elements by increasing atomic number to remove inconsistencies in Mendeleev's periodic table. This created repeating patterns of chemical and physical properties known as periodic law. In the early 1940s, as scientists raced to develop the first nuclear weapon, American chemist Glenn Seaborg discovered heavy elements with unique properties. He then suggested that moving elements 58 through 71, known as the lanthanides, and 90 to 103, known as the actinides, to the bottom of the periodic table would better reflect the idea that elements within the same group have similar properties. Now, the periodic table looks like it does today. The modern periodic table contains 118 elements organized by increasing atomic number into 7 periods or horizontal rows and 18 groups or vertical columns. Elements can be classified into 3 broad categories based on their physical properties. Metals comprise the majority of elements and are located on the left side of the periodic table. Nonmetals are located on the right side of the periodic table, with the exception of hydrogen. Metalloids are found between metals and nonmetals on the periodic table.